So this is the trick problem practice, and the trick is if the Kc is equal to -10th, or to 1.1 times 10 to the -10th, or lower, then you can just cancel out the x. So here's the table to the equation that we set up. We just plugged in the variables. The problem was at 950 Kelvin, the Kc for the following reaction is 2.97 times 10 to the -19th. If the initial concentration of N2 is one molarity, or 1 molar, 0.1 molar, and the initial concentration of H2 is 0.2 molar, what are the equilibrium concentrations of the components of this reaction? So we had there's an N2, which is nitrogen, and then H2, which is 2 hydrogens, or 3 hydrogens, and then that combines to make a 2NH3. And so when we set up the table, it's 0.1 molar with minus x on that side with the 0.1 minus x, and you can see the rest of it. And so when we did the problem, here's the problem. You set up the Kc, and that's equal to NH3 to the second power over N2 times H2 to the third power. Then the Kc is 2.79 times 10 to the -19th equals 2x squared over 0.1 minus x times 0.2 minus 3x to the third power. When you then you set up the problem again after doing the. So when we recorded this, we forgot to cancel out the x's, but the x's, this x, which actually should be canceled out, this x, and then the minus right there, and the negative 3x should be canceled out actually. So just so you know that. Let me delete that too. So, oh, I guess we did actually cancel it out. Sorry. So then after multiplying and dividing, we got this, and the answer starts to go out to 2.232 times 10 to the -22nd equals 4x squared. And then simplifying it even more, when you divide the 4 across, you get 5.58 times 10 to the -23rd equals 2x, or x squared, and then getting rid of, when you divide by, when you do the square root on each side, you get 7.4699 times 10 to the -12th equals x, and then you fill in the molar values on the table, and you get, for the molar value of 2NH3 is 0.149 times 10 to the -11th. And then that is how you do the trick, and it's really easy. You can do this. It always works every time, and that's pretty much it. Thank you.